lesson 78, the final lesson in this unit. In this lesson, we're going to solve systems of linear and quadratic equations. So again, when we're talking about solving systems, we want to know when do they intersect. And because a quadratic equation can actually be, can hit at multiple points, it's possible they may have, again, either 0 solutions, 1 solutions, 2 solutions. Those are all possibilities here. So this is what we're going to do. We're going to use our tools, our calculators to graph both functions. We're going to use the graph and the table of values to identify points of intersections. And if the points of intersections consist of decimals, then really use that trace feature on your calculator in order to identify, get as close as possible to intersection. So let's jump in. So just some high-level notes. If you have a graphing calculator, this is what you could do on a TI to actually to find the points of intersection. You can click y equals and make sure your calculator looks like this so that you can type in both equations. So that's something you can do, and you notice here one is linear and one is quadratic. And once you do that, you're going to click second and that graph button so you can see all your tables. Now, depending on how computers and calculators advance, maybe there might be a second function, but this is for the current in 2023, how I would do it on a regular graphing calculator. And notice you can see your first equation, y1, and your second equation, y2. So y1 is your quadratic, here's your linear, and they're listing all the points at x. And you can find the 2 points where they intersect, like where they're exactly the same. So when x equals 1 and x equals -2, it intersects both times. So there are 2 points of intersection. So that's the first part, and this is already in your notes. You don't have to jot any of this down. Let's look at this example together. John and Sarah are each saving money for a car. The total amount of money John will save is given by the function f of x is equal to 60 plus 5x, so it's linear. And the total amount of money Sarah will give is given by the function g of x is equal to x squared, apologize about the square symbol, plus 46, so we have this quadratic. After how many weeks, x, will they have the same amount of money saved? So that's what we're going to look for. When do they intersect and at what week or weeks? So let's take a look. We're going to try and do it algebraically first. And so I just want to figure out when f of x is equal to g of x. So you're going to solve this the way we normally would. And we're going to set this to 0. All right, we're going to factor 14, and -14 factors that add up to -5, so we want the higher factor to be negative. And that gives us x is equal to 7 or x is equal to -2. Now, because x talks about weeks, this can either be 7 weeks or -2 weeks. That doesn't make any sense, does it? So we're going to just cross out this one, as for the context of this problem, it just doesn't work. So it says here at 7 weeks. So let's confirm this on our graph, and I'm going to pick up decimal so we can actually see it there and see what happens at 7 weeks. All right, so I just did a quick screenshot so we can see what it looks like with both of our equations set in there. And you can look and identify there is a point. There are actually 2 points where x is equal to the same. And we have here the one that we wanted to find, 795, and we also have the -250. So those are the places where they're exactly the same. But again, that first one doesn't make sense in the context of the problem. So our real solution is here at 795. And you can see it on our graph that that's where those 2 functions intersect. It does happen here and it does happen here. But again, we're not looking for negative time. So all you'd really have to do is take the points that we have listed out to graph both of them here. We're going to go to 7 weeks. So 1, 2, 3, 4, 5, 6, 7. I'm going to have this going up by tens. Okay, so we have it. And then you're just going to graph them linearly. So 95, let's put in that point here. So that's 90. So this is about 95. So for my linear one, I have 0, 60. And I have 270. And then it just go, and I have the rest of the points going in there. So I'm just going to draw that line. There we go. So that's all I would do. And I would actually just put in that equation for John. So we already have it. So there's J, John. And I would just do the same thing for the quadratic one. So the points happening here for our quadratic, and it starts at 0, 46, so kind of around here. Around there, that's where it's starting from 0. And then I'm just looking to see, are there any other points that are easy enough to do? Well, 250, it's kind of easy. And then I have the last one at 7. So it's definitely a curved line going like this. Okay, so that's all I did. Obviously it's not perfect because again, I'm only looking at this part of the graph. This is the only thing I'm really graphing, so it's not easy, but at least I have a few points there. And let's make sure that I also have that equation x squared plus 46 in there for Sarah. And I want to make sure I identify the solution on my graph as well. 795, 7 weeks. They'll both have $95 saved. Okay, so let's hit pause and jot this down into our notes. Okay, let's try one out before we get to our checkpoint. Here, try to graph these two equations on your graphing calculator or using Desmos and identifying where they intersect approximately. Notice they are decimals, so if you have your graphing calculator, use that trace function to really find out about where is that point. And if you are using Desmos, you're probably going to have to zoom in. So hit pause, get to work, and we'll do the spoiler reveal in a moment. Okay. Here we go. We're going to just take a look in. I can see my graph and I can absolutely see that there are 2 points of intersection happening. So we're going to eliminate the first 2 altogether. And now we're just going to look at this second set. And the first one is the same. So I'm going to focus here and see which of these points is true. Is it 2.68 or 3.85? Okay, so again, we already have our first one. Notice on Desmos, and again, you free. You can use it from home on your computer. You can see they just rounded to the nearest thousands. Our answers are to the nearest hundreds. So that was our first point, 0.38, 38 hundredths, and negative 2 and 85 thousandths. And our second point is up here. So 2 and 618 thousandths, 3 and 854 thousandths. So they're just rounding this to 2.62 and 3.85. Which makes our answer C. So there you have it, Math Marvels. That's all we have to do. I'm just using the tools that we have, and I love that there are so many awesome resources that are available to us. So if you have a graphing calculator, that's fantastic. And if you don't have access to one, go to Desmos.com and use it to find the solution to a quadratic and linear equation. That's it for today. Use this information before to get your feedback in and during your practice so you can build your own accuracy. And I will see you in the next lesson, Math Marvels, a brand new unit. Be well.